So in this video we'll start up with exercise 10.1. Okay. The first question: represent graphically a displacement of 40 kilometer
30 degrees
of north. That means the magnitude of the displacement is 40 kilometer and the direction of your displacement is 30 degree east of north. 30 degree east of north means from north you go 30 degree towards the east. Suppose 60 degree west of south. Just example. 60 degree west of south meaning this is your south, this is your west, this is your east, this is your north, right? North, south, east, west. 60 degree west of south means from south you go 60 degree towards the west. Then this is your vector. The length of this line shall give you the magnitude. Is it okay? Yeah. So here the magnitude of the displacement is 40 kilometer and the direction of the displacement is 30 degree east of north. So from north we are going to go 30 degree towards east. Okay. So this is your north, this is your south, this is your west, and this is your east. We want to represent the displacement, which is 40 kilometer magnitude, and 30 degrees of north means what? 30 degree east of
from
north means
north to east.
from north to east you go 30 degree. Then this vector gives you the displacement. So this is 30 degree. And the length of this vector should be what?
40 kilometers.
40 kilometer. That is how we represent a vector graphically. Okay? Yes. The second question. Classify the given measures as scalar or vector quantity. So what is your first given quantity? In question number 2. In your textbook, Roman 1.
Number 1, 10 kg.
10 kilogram. What does this 10 kilogram represents? What quantity is this? Which physical quantity does
Scalar.
10 kilogram represent? Which physical quantity? Time, length. Does 10 kilogram represents time? No, right? So which physical quantity does this 10 kilogram represents?
Mass.
Mass. Right? Yes, mass. If we talk about weight of an object, no? The weight of an object always acts downwards. So it has a direction. But in this case, since nothing is being specified, so we'll consider this 10 kilogram as mass. Mass of an object means always remains constant. It has no direction. Is it okay? So it is a scalar quantity. Mass, it's no direction, right? No? Yes.
2.
Number 2.
2 meters northwest.
2 meters north,
West.
northwest. 2 meters northwest. What does it have a direction here? The quantity is 2 meter, the magnitude is 2 meter. And what does this northwest represents? The direction, northwest. Northwest means this is your north, south, west, east. 2 meters northwest means this is your northwest direction where the angle is 45 degree. Here also the angle is 45 degree because the angle between north and west is 90. Okay? So this directed line represents
2 meters.
your 2 meters north of west. Is it okay? Yes, that means your vector is in a direction of 45 degree west of north. So this is a vector quantity. Okay. Number 3,
40 degree.
40 degree. 40 degree what? Towards east, towards north, towards west, towards south, nothing is given. So no direction is specified, so this is only magnitude. Is it okay? Yes, so we cannot say this is a vector quantity. Okay? Yes. The fourth one,
40 watt.
40 watt. What does this watt represents? What is the unit of?
Time.
What is the unit of time? Time means second, hour, days, months, years, decades, centuries, right? How comes what is time? What is the unit of power? Power, electric power, right? Power does not have any direction. Is it okay? What is the power of this bulb? 15 watt, 9 watt. Is it okay? What is the power of this electrical heater? 1600 watt. Your rice cooker, 1800 watt. Is it okay? So power do not have any direction, they have only magnitudes. Alright, so it is a scalar quantity. No? Next.
10 to the power minus 19 coulomb.
10 to the power minus 19 coulomb. Oh, what is this coulomb? 10 to the power minus 19 coulomb means it's a charge. Charge of an object. And charge of an object has no direction. Is it okay? Any object possess charge. And charge, they do not have any specific direction. If you talk about electric field, then electric field always acts
Radially outwards.
for a positive charge. Electric field always acts radially positive outwards. Radially outwards. And for a negative charge, electric field acts radially inwards. So electric field, it has a direction. But a charge, it does not have a direction. An isolated charge. Okay, it does not, charge means it does not have a direction. But for an electric field, it has a direction. Okay? Yes. Next.
20 meter per second square.
Number 6 is 20 meter per.
Second square.
What does this unit meter per second square represents? Velocity means meter per second. But meter per second square represents acceleration. Is it okay? So acceleration is a vector quantity. Alright? Yes. Done. Similarly, for question number 3 also you can do, just to classify. Now let's work out question number 4. In question number 4, what do we have?
There's a figure given.
Okay, a square is given in which the 4 sides of the square are represented by
Vectors.
the 4 vectors. Okay. So in question number 4, a square is given. Square means all sides are equal, right? So the side of this square is represented by the vector A, side of this square by vector B, side of this square by vector C, and side of this square by vector
D.
D. Since all the sides of a square are equal, so the magnitude of all these 4 vectors will be equal. Magnitude of A will be equal to magnitude of B will be equal to magnitude of C is equal to magnitude of
D.
magnitude of vector means the length of the side of your square, right? And all the sides are equal, so magnitude of all the vectors are equal. So in the first case, you need to identify which of them are.
Vectors.
Question number 4.
Co-initial.
Co-initial vectors. Co-initial vectors. Co-initial vectors means vectors having the same initial point. Okay? So in this figure, can you name any vectors having the same initial point?
Vector A and vector D.
Yeah, vector A and vector D have the same initial point. So they are co-initial vectors. So vector A and vector D. That is how you have to write. Okay? What about the second one?
Equal.
Equal vectors. 2 two vectors are said to be equal if they have the same magnitude as well as
Same direction.
direction. So can you tell? Okay, all of the four vectors have equal magnitude, but you need to check for the direction now. So can you? Is there any two vectors or three vectors which are equal, which have the same direction?
Vector D and B.
Yeah, B and D. Of course, magnitudes of all of them are equal, but the direction of here B and D are also equal, right? B is pointing downwards. D is also pointing downwards. So vector B and vector
D.
Next.
Collinear but not equal.
Collinear but not
Equal.
collinear vector means two vectors are said to be collinear if they are parallel. If they are parallel, they may have equal, different magnitude, we do not care. They may have same direction, different direction, we do not care. But they must be
Equal. Not
parallel. They must be parallel. But
not equal.
we are not going to take the equal vectors, okay? That means we are not going to consider B and D. B and D are equal vectors, so we are not supposed to take the equal vectors here. So we'll only go for the parallel one. Can you see any vectors which are parallel here? Which one? Parallel? Parallel.
TB and AC.
B and D are parallel but also equal, right? But they are saying they should not be equal. B and D, why are they equal? Because they have the same direction. Of course they are parallel, they are also collinear because they are parallel. But since they are equal, so I'm not going to consider in this situation. Because you want your vectors not to be equal. So B and D has to be rejected. Okay? So?
A and C.
Yeah. Even though the directions of vectors A and C are opposite, they are parallel to each other. So that makes them to be collinear. So vector A and
C.
Are you following that? Yes. So I think that ends up our first exercise 10.1, no? Okay. Now we shall move on to the second exercise. Exercise 10.2. Let me give you some idea about addition of vectors, okay? Addition of vectors. Suppose in class 11, physics, you have studied about triangular law of vector addition and parallelogram law of vector addition. Okay? Suppose if two vectors are represented by two adjacent sides of a triangle in this order, okay? They do not have the same initial point, okay? They do not have the same initial point, alright? So if two vectors are represented by two sides of a triangle, then their sum means vector A plus vector B. Then their sum, which is known as vector A plus vector B, is given by the third side of the triangle. Is it okay? Third side of the triangle taken in opposite order. Means, see, this vector, they are in same order, not same order. Means if the vectors are joined from tail, head and tail, if suppose see this vector, this is the head of the vector, this is the tail. You join another vector like this. These two vectors are joined from head to tail. Is it okay? Head of one vector is joined to tail of another vector. That means these vectors have the same order. But if two vectors are joined head to head, they have different order. Is it okay? So if two vectors are represented by two sides of a triangle in magnitude and direction taken in same order, then their sum, a plus b, is represented by the third side of the triangle in magnitude and direction taken in opposite order. So this will be your a plus b. This is known as your triangular law of vector addition. And triangular law of, and addition of vectors satisfies commutative property. Means vector a plus vector b is always equal to vector b plus vector a. So it satisfies commutative property of addition. Okay. We have another addition law known as parallelogram law. In parallelogram, what we do? If two vectors are represented by two adjacent sides of a parallelogram joined tail to tail, then their resultant will be given by the diagonal of the parallelogram drawn from the same common point. Okay? Let me see. If two vectors are represented by two adjacent sides of a parallelogram, suppose this is your vector A, this is your vector B. If two vectors are represented by two adjacent sides of a parallelogram, joined tail to tail, or having the same common point, as having the same initial point, in magnitude and direction. So if two vectors are represented by two adjacent sides of a parallelogram, okay, having the same initial point in magnitude and direction, then their sum, vector A plus vector B, suppose, let me complete the parallelogram. So your parallelogram is completed now. Then their sum, vector A plus vector B, is given by the diagonal of the parallelogram in magnitude and direction drawn from the same point, initial point. Is it okay? Yes. So this vector will be vector A plus vector B. That is what you need to know here. Alright? Yes. Okay. So let's try some of the exercises. Yeah. In question number 1, what are you asked to determine here?
Compute the magnitude of the following vectors.
Oh, you have to find out the magnitude of the following vectors, right? What is your first given vector?
Vector A is equal to
Vector A is equal to
I unit vector plus J unit
I cap plus J cap
plus K
K
cap.
cap. That is your first vector. Okay, and then?
In bracket.
Okay, it's alright. Yeah. And I'll do another one. Vector C is
1 by root 3
1 by square root of 3 I cap
plus 1
plus
by root 3
square root of 3
J
cap
minus 1 by root 3 K
minus 1 upon square root of 3 K cap. So you have to find out the magnitude of these vectors. I'll do for the third one. This is your vector C. Then magnitude of this vector will be represented like this, right? Magnitude of C. And it is given by what? Square root of component of x square plus component of y square plus component of
Z square.
z square. Is it okay? So 1 squared is 1 upon
3
plus 1 by 3 minus square is positive, so 1 by 3. So that is equal to 3 is the LCM. So 1 plus 1 plus 1 square root of 3 upon 3, which is equal to square root of 1, that is equal to 1. That means C is a unit vector because its magnitude is 1. Are you following that? Alright. Okay, we can go for the second question then. What is your question number 2?
Write two different vectors having same magnitude.
Oh, write two different vectors
Having same magnitude.
having the same magnitude. Suppose what you have to do is what the question says. I'm not going to solve this. You are going to do it by yourself. Okay. Okay, let me do one and you will do another one. Okay. You want to find two vectors having the same magnitude. So in that case, so let A be your vector 1 by root 3 I cap plus 1 by root 3 j cap minus 1 by root 3 k. This is one vector. Let B be another vector 1 by root 2 I cap plus 1 by root 2 j cap. Whereas its z component is 0. Are they equal here? They are different, right? Now let's find out their magnitude. Okay, and their magnitude should be equal. Now, so magnitude of A means square root of 1 by square root of 3 square plus 1 upon square root of 3 square plus the z component 1 upon square root of 3 square. So this is 1 by 3 plus 1 by 3 plus 1 by 3. That gives you
3 by 3.
3 by 3, which is equal to
1.
square root of 1. That is
1.
1. So magnitude of your vector A is 1. Let's go for B. Magnitude of B means square root of the x component plus the y component square, right? So this is 1 by 2 plus
1 by 2.
1 by 2. That is 2 by 2, which is equal to square root of 1. So see, two different vectors having the same
Magnitude.
Okay? Yeah. What is the third one?
Two different vectors having same direction.
Oh, two different vectors having the same direction. Having the same direction. Means two different vectors having the same direction. In that case, you need to find out, suppose let A be any vector, B be another vector. Okay? Then you have to find out a unit vector in the direction of A. That means unit vector representing the direction of your vector A will be denoted by A cap. Is it okay? And how do you find A cap? Vector A upon magnitude of
A.
So you have to find unit vector because unit vector gives you the direction of your vector. So A cap will give you the direction of
Vector.
A, right? Similarly, let's find out the direction of this vector B as well. You can choose B as to be any vector, okay? And then you need to find out its direction because direction of vector B will be given by unit vector B cap. Unit vector B cap means vector B upon magnitude of B. So this unit vector gives you the direction of
B.
Now if A cap and B cap are equal, that means direction of A and direction of B will be equal. Hence, that will give you the complete solution. Is it okay? Yes. All right. Next one, we'll go up to 5 first. Next question. Question number 4.
Find the scalar and vector components.
Question number 4.
Sir, in number 3 we'll also put like this, right? 1 by
That is, you can search for any example that you like. Okay. Yeah. So number 4.
Find the values of x and y.
Oh, find x and y, no? Find x and y so that
the vectors 2 I cap
so that the vectors
2i cap plus
2i cap
3j cap
plus 3j cap
and
and
xi cap plus
xi cap plus
yj cap are equal.
yj cap are equal. Oh, two vectors are equal, right?
Mm.
These two vectors are equal. And with that, we need to find out x and
Y.
y. So shall we do like this? Let vector A be 2i cap plus 3j cap. Okay. Let your vector B be xi cap plus y
J cap.
j cap. It's given that your vector A is equal to your vector B. Vector A means 2i cap plus 3j cap is equal to vector B means xi cap plus y.
J.
So if two vectors are equal, x component will be equal to the x component, y component will be equal to the y component. Therefore, your x will be equal to 2 and your y will be equal to
3.
Alright? Yes. Now we'll go for the fifth one. What is your fifth question?
Find the scalar and vector components
Find the scalar and vector components, okay?
of the vector with initial point 2, 1 and terminal point minus 5, 7.
Oh, okay. You want to find out the scalar and vector quantity now of the vector
Component
having
initial
initial point and
terminal point.
terminal point. This is your x-axis, y-axis, z-axis. This is your origin. What is your initial point?
2, 1.
Your initial point A ni coordinate is 2, 1. And your terminal point is,
Minus 5, 7.
let's say it's B ni, B with coordinate minus 5, 7. So you need to find a vector having A as the initial point and B as the,
Terminal point.
then this is your vector. That means you have to find out vector AB and its magnitude. Okay? So vector AB is what you need to determine. Okay? And how do we find out this vector AB? How do we find out this vector AB? Position vector of B minus position vector of A. Position vector of B will be vector OB. Now, position vector of A means vector OA. Correct? So position vector of A means vector OA. And how do we write position vector of A? 2i cap plus
1 j cap.
j cap. 1 j cap. Right? And how do we write position vector of B?
Minus 5
Vector OB, which
cap
is equal to minus 5 cap
plus 7 j cap.
j cap. So vector AB means your position vector of B minus position vector of A. Position vector of B means minus 5i cap plus 7j cap minus, and then vector OA 2i cap plus 1 j cap. So minus 5i cap plus 7j cap minus 2i cap minus 1 j cap. Minus 5 minus 2 minus 7. Only the x and x component can be added. Y component can be added to y component only, okay? X and y components cannot be added. Minus 7 7 minus 1
Plus 6
6j. Alright? That's your vector AB. We need to find its scalar also means magnitude. Now, so magnitude of AB will be square root of x component square plus y component square. That is 49 plus 36, right? That is 15, 4, 5, 6, 7, 8 units. Alright?